All right, section 4 starts talking about radians, arc length, and angular speed. And this is the section where you really need to make sure you have that unit circle that's on the back cover of your textbook readily available for you. Okay? First of all, radians is another way to measure on a circle. And it has to do with a circle that is centered at the origin with a radius of 1. And this is what we call the unit circle. So in other words, we use radians to make measurements on the unit circle. Okay? Now, the circumference of a circle is 2 pi r, and this is just a formula that you've seen time and time again. So for a unit circle, the circumference is 2 pi. Because when the radius is 1, you have 1 times 2 times pi, which is just 2 pi. And don't forget, circumference is the distance around a circle. If you were to take that circle and break it in half, or not break it in half, but break it and stretch it out as a line, the distance would be 2 pi, or whatever the value of 2 pi is, because don't forget, pi is an irrational number. So any number that we say 2 pi is, where it's just actually an approximation. Okay? Now, what's important, take a minute to look at the unit circle. Okay, again, centered at the origin, it's supposed to be a perfect circle here. Radius of 1. A 90-degree angle, or what we consider to be a 90-degree angle, in radians is what we measure pi. A 180-degree angle, or a straight angle, is what we measure, or excuse me, pi over 2. This is pi. If we take an angle all the way around 360 degrees, we end up with 2 pi, because that's the circumference of the unit circle, or a circle with radius 1. Okay? So, as an example, just to get comfortable looking at this unit circle, how far will a point travel if it goes one-fourth of the way around the unit circle? And we're talking about a point on the unit circle that travels around on the perimeter of the circle. So if you look at the unit circle, if you travel a fourth of the way around, the point has gone pi over 2 radians. And radians, by the way, is unitless, so it's not like inches or centimeters, or it's unitless, it's just radians. What about, hold on 1 second, let me make sure I'm on the same example. Okay. The way to calculate this, if you didn't want to look at the unit circle, is just to multiply 1/4 times 2 pi, with 2 pi being the radius. 2 over 4 simplifies to 1/2, so you end up with pi over 2. That's how you get there. It's not always as obvious. What about if we look at 1/12 of the circle? Well, the strategy again would be to multiply the 1/12 times the 2 pi, which is just pi over 6. And I'll bet if you look at that unit circle, you can see where it says pi over 6. Yeah, the unit circle gives measures in radians as well as coordinates. So, and the coordinates correspond to the triangles that are formed from the corresponding angle. Okay, so on and so forth. All right. So important to look at example 1. Look at the pictures on page 522. Example 2 is important. And then we skip into what we call radian measure. Recall that the radius is 1. Suppose we move counterclockwise. And don't forget, counterclockwise is a positive movement. And measure an arc length of 1. Mark that point as T. And T is an arbitrary label. So let's draw what we're looking at here. You have a circle. You know your radius is 1. You move in a counterclockwise position, so you have an angle. The point's moving along the circle. Where it stops, we call that point T. If we draw, which we already did, a ray from the origin to T, we formed an angle. With a measure that is 1 radian. Again, I said it just a second ago, radians are unitless. To go from degrees, it's important to be able to go back and forth, to radians and back is really important. You need to be able to go back and forth from each one. So to go from degrees to radians, you multiply your degree by pi over 180 radians. To go from radians to degrees, you multiply your radians by 180 over pi radians. The radians actually goes in the denominator. Okay, it's a pretty straightforward process. So just looking at an example, if we wanted to convert 120 degrees to radians, what we would do is write just 120 degrees. We would multiply, we're going from degrees to radians, so we're going to multiply by pi over 180. Okay, and 120 divided by 180, you can leave it as a fraction or you can divide it out, is, actually I'm going to leave it as a fraction, is 6 over 9 pi, which reduces or simplifies even further to 2/3 pi. Yeah, that's right. Okay, so that's interesting because if you look at the unit circle on the back cover, look for the radian measure of 2/3 pi. If you notice, it's in the second quadrant and it's right where 120 degrees is. So it's somewhere right about here. So the measure in degrees is 120 degrees. It's 120 degrees to get here. But the measure is also 2/3 pi. Okay? Another example would be if we wanted to convert 3 pi, 3/4 pi radians to degrees. We're going from radians to degrees, so we would multiply the 3/4 pi times 180 divided by pi radians. Your pi's cancel, okay? And then, let's see. It's 180 divided by 4. Later in the day it gets, the worse my arithmetic skills get. 45. So 3 times 45 is 135. So it's 135 degrees. Okay, so what's interesting about that is if, again, you look at that unit circle in the back, at 135 degrees, it clearly states the radian measure is 3 pi over 4. And in fact, it's just a little bit further than this. Okay, so this would be 135 degrees, but it would also be 3 pi over 4 radians. All right. The text goes on to mention how to find arc length and central angles. It's a pretty straightforward formula. On page 527, the discussion starts. Take a look at that. Take a look at the examples. Then page 529 starts talking about linear speed and angular speed. And linear speed is the speed that something moves along a line. Angular speed is how quickly something is rotating in either a clockwise or counterclockwise direction. And I actually think the text does a pretty good job of explaining both of these and gives a nice discussion and a pretty simple formula to look at on page 529 for this topic. So you should be okay reading the text. And then, you know, like always, if you're not, shoot me an email. I'm happy to try and clear anything up. Or if we need to meet to work on it, I'm happy to do that as well. So, okay.